Welcome to lesson 14, theoretical probability of an event. Or actually, what? Calculating? Determining theoretical probability of an event. We're going to gamble today. That's just fun. Right. Do you know what these are the odds for? 1 in 1,296. Should I tell you? Or should I wait? I think I'm going to wait. I want you to guess. It has to do with a game and getting like a perfect score. So think about that. Right. Let's talk about some vocabulary for us today first. If you got your calculator, that'd be good because there's a probability simulator on there that will do some of the kinds of things that we have today, and you could actually use it to run what's called a simulation if you want to. But the simulation is not really what we're interested in today. Today we're interested in determining the odds, we could say, or the theoretical probability of something happening. I've got some different colored dice in a bag. Get my calculator handy here as well, but a lot of it's just thinking through how something would work. What are all the possibilities for a particular result to occur? See the glitch in the matrix. So I'm just going to pull up my probabilities simulator here on the calculator, and remember from a little while ago we saw that there was lots of different options for us. There's coin tosses and dice rolling and picking marbles out of a sack and spinning spinners and drawing cards and then choosing random numbers. So if you are playing a particular game or you're looking for particular odds, you might pick one of these, a different one of these, in order to simulate the probability of different events. The spinner, you can, once you go there, it has 4 sections, different colored sections, but if you press the button that says set, you can change it from anywhere from 2 up to 8 sections. So maybe you played like the Game of Life. It has a lot of sections on its spinner. Or if you were ever on the game show The Price is Right, their spinner thing's got lots of sections. Actually, The Price is Right's really great for this kind of stuff because people make seriously irrational decisions on these games because they know nothing about probability. And somehow some people still win. So you can have something that's set up like this with 8 different evenly sized pieces so that when you spin the spinner and it goes round and round, it has an equal probability of landing on any one of those 8 spaces. Let's talk about vocabulary first, though. I got 3 things in there, and if you're using the book, lesson 14, page 74, there's the 3 are in under the new concepts right there at the beginning of the lesson. First is sample space. Sample space is where we think of all the possible outcomes of an event. Okay, and an event, that one comes next, is simple event is an event having only one outcome. So maybe it's like rolling the dice and getting a number, or flipping a coin, or it's doing the Plinko game where you've got a series of little slots that your little disc can fall down to. I guess now they have one that's like the wall, and a ball bounces down, and which thing is going to fall on, like carnival game types of things. So sample space is usually written with brackets or braces, and then you're just writing down all the things that you could get if you, let's say, roll the dice. So sample space for rolling a dice, 1, 2, 3, 4, 5, or 6. That's typical sample space. It doesn't have to be numbers, though. You could have, for flipping a coin, heads or tails. And there's a small percentage that it could land on its edge, but at that point you just flip it again and get a head or a tail. So there you go. I just listed all the possibilities that I could get if I carry out a particular event, like flipping a coin or It could be pulling out a card, for that matter. And then what are the chances that you get a king? It'd be 4 out of 52 or 1 out of 13. Your sample space for a particular event, let's say pulling out a king, you'd have to list all 4 suits of those kings. King of hearts, king of spades, king of diamonds, king of clubs. So those two go together. Simple event, I'm going to flip a coin, I'm going to roll a dice, I'm going to pick a card, I'm going to choose a marble. I'm going to take a number out of a hat. Theoretical probability is what we're talking about today, and that is found by analyzing a situation in which all outcomes are equally likely. That's the first point. Everything has to be to have the same chance of happening here for theoretical probability, and then finding the ratio or the fraction of favorable outcomes to all the possible outcomes. And that's how we have this here as a way to calculate these things. So the probability of an event, got the number of favorable outcomes. And you don't even have to list them, you just have to count them. They have to be countable. Okay, they have to be what's called discrete. Compared to the total number of things, total number of outcomes. So let me give you an example. Probability of rolling a dice and getting an even number. Just one dice, even number. Well, we might start thinking about the sample space and we think, well, that's a 2, 4, or 6, right? 2, 4, or 6 are all the even numbers that you could get by rolling a dice. So that's 3. 3 possible things of favorable outcome. And then what are the total number of outcomes? Well, there's our sample space for the total number of outcomes. And there are 6 different things in there. So the probability of rolling an even number on a dice is 1/2, 50%, or 0.5. Pretty simple concept. You just have to look at what is the thing. In their first example, they asked for just sample spaces. And the first one is a number less than or equal to 3 when we're rolling a number cube, when we're rolling a dice. Okay, so what do we get if we roll this? What are the possibilities here on this thing of rolling something that's less than or equal to 3? Well, that would be a 3, a 2, or a 1. 3 of those compared to the 6 total outcomes if you roll a dice, but there's our sample space, will be 3, 2, 1. Or their sample space being an odd number or a number greater than 4. Well, 5 and 6 are greater than 4, and so it wouldn't include 4 in that case because it must be greater than. So we're going to use this probability of an event. This is something that you're going to want to write down. This will help you kind of just sort through those things and actually get a number. But you're going to have to think about all the different possibilities that you get, and then count up the ones that are what the event happens to be. There's one more vocab there on the next page on 75, and it says a complement of an event is the set of all outcomes of an experiment that are not in a given event. So that would just be like, well, what are the chances of rolling a 1 or 2? And then what are the chances of not rolling a 1 or 2? That would be the complement. That would be the thing that's the rest of the set that you didn't use. So why would you ever need that? Because typically in games they'll tell you the probability of winning, okay? But they don't tell you the probability of losing because then you wouldn't play. Different card games or different games at like a casino or something, like you got roulette or you've got craps. They're going to tell you the probability of winning with certain types of rolls or spins or whatever, or bids. But they're not going to tell you what are the odds of losing because those are greater than the odds of winning. But you should think about those as you make decisions about what to do. Okay, I'm going to drop the ball now. And that would be, let's talk about what that 1 in 1,296 is. I was just going to mention Yahtzee. And that's the probability of getting a Yahtzee on your very first roll. You just pick up the 5 dice, you roll them, and they're all the same number. You have a 1 in 1,296 chance of getting that. Now, that doesn't mean that it can't happen. It just means that it's very unlikely that it will happen. But if we're talking about theoretical probability, there it is. Now, I've seen people do this experiment, and they've just rolled it and picked it up and rolled it, and they kept track of how many they did. And a lot of people get it before 1,296, and some people, it takes them more than 1,296 rolls in order to get a Yahtzee. But what we're doing here is just mathematically calculating what are the chances. I'm not going to lay it all out. There's lots of good videos you can go watch. Maybe I'll put something in the description below so that you can see a Yahtzee video. And if you ever get one, you have to have a dance. You have to have a dance, a victory Yahtzee dance, so you can taunt your opponents that you just got a Yahtzee, especially if you get it in one roll rather than just 3. So there you go. You might have a problem where you've got things in the bag and you're just reaching in there. You're keeping track of what you get. Oh, I got black again. What were the chances? The only problem is these are like different shapes, so I can I'm trying not to think about it. I'm just trying to reach in and grab something. The probability of getting any one color here is 1 out of 5. So if I did this enough times, I should get each color about 20% of the time. But it's not guaranteed, but that's the theoretical probability of that happening. So calculate your chances. It's just counting up how many things are there that would win compared to how many things are there altogether, possibilities. That's pretty much it, and then you go from there. Okay, use that basic little formula there, number of favorable outcomes compared to the total number of outcomes, turn it into a fraction, a decimal, or percentage, and you got the right idea.